Our series debut is sponsored by Littelfuse. Littelfuse is a global manufacturer of leading technologies in circuit protection, power control, and sensing. Littelfuse partners with customers in over 150 countries to design, manufacture, and deliver innovative, high-quality solutions for a safer, greener, and increasingly connected world. Everywhere, every day. Learn more at littelfuse.com.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. It's our debut episode, and we're talking about design engineering during the COVID-19 pandemic. For the first time in over 100 years, a global pandemic has necessitated shelter-in-place orders affecting every corner of every industry. We in the electrical engineering profession may not be responsible for providing life-saving medical care, but we do develop the technologies that have made much of the COVID-19 response possible. Unfortunately, we have something of a catch-22 on our hands. The very virus we're trying to combat is restricting our access to the tools, techniques, and people that help us get the job done. Though engineering is sometimes a rather solitary activity, our profession is actually built on teams. We lay out specifications together, consult one another on designs, and spend long hours together in the lab. Working remotely has presented many challenges as we're separated from our teammates, our design tools, and the labs and equipment we need to verify our designs. Modern teams have many collaborative tools available to help them work beyond physical boundaries, even with teammates scattered across the world. But traditional workplaces were definitely not prepared to go full remote, just yet. So, how are we coping? In this debut episode, we'll hear the voices of 3 engineers who are navigating the pandemic in different ways. We'll talk to a senior staff engineer at Lockheed Martin Space who explains why collaboration is key for engineers.
Part of it is just the camaraderie. Togetherness is important, especially when things get tough. I mean, you can have a really, really bad day in space.
We'll speak with a manager at Royal Circuit Solutions, a PCB fab house that has stepped in to help expedite the production of vital ventilator components.
You cannot experiment ethically. You cannot experiment with a human life. You just can't do it.
But first, Russ Croman, Vice President of Engineering at Silicon Labs, joins us from his home near Austin, Texas. Silicon Labs, a fabless semiconductor company, employs engineers across the globe, over 500 of which work on research and development for products that combine hardware and software, which need to be architected together. At the moment, that's easier said than done.
Yeah, the work from home situation is interesting. When this was all starting to happen, and it was obviously starting to happen pretty quickly, I think we were ahead of the game in that we started laying plans for how we would work prior to any action being taken in terms of a shelter in place or work from home. Mm-hmm. So we'd already started organizing ourselves into alternating teams that would alternate, say, every 2 weeks coming into the office and figuring out how we would work together, how those two teams would avoid working together, and how we would manage the logistics of access to lab equipment and things like that for, working with our products and validating them and qualifying them.
Right.
After we worked that out, pretty quickly, we realized actually hardly any of us are going to be coming into the office. Almost all of us are going to be working from home, with the exception of a small crew of really critical employees that really, to do their work or to assist the rest of us in doing our work, really have to come into the office to set something up in the lab, change a lab equipment setup, et cetera. Some of that equipment is very big and heavy and isn't really workable to, transport that to home locations to do that from there.
Sure.
So pretty quickly we went into a full, work from home situation. And I'd have to say it's going better than we initially expected. We're actually making quite a bit of the normal progress that we would have been expecting to make on the various projects that we have going on, even working remotely. And an interesting aspect of it is what I'm hearing from the teams that are located in other parts of the world. They're actually finding this a bit better in some ways. Because before, we'd have a big team meeting in Austin with folks dialing in from other locations in the world, and they always felt like the remote employees. They always felt like kind of on the outskirts, and what this has done is kind of leveled the playing field between the local folks and the folks that are dialing in remotely. So now everybody feels like they're equal members of these meetings. That's actually, in some ways, there are some positives to this. It's interesting.
What have you noticed with respect to productivity?
I'd say if we have a project that's in the design phase, in the architecture or design phase, where most of the work happens on the computer anyway, that's actually going pretty much as efficiently as it was when we were in the office. If we have something that's in the validation or qualification phase where you need hands-on the hardware, you need to be connecting it to test equipment and making measurements. We are making that happen with the arrangements I mentioned earlier, with the different teams and very tight safeguards about avoiding mixing of employees when they're in the office and that sort of thing. It is going a little bit slower, but still significant progress is being made. We're keeping things pretty on track, which is really nice to see.
Yeah, and presumably all of your designers and application engineers have sufficient access to their design, simulation, and validation tools?
Yeah, we, for about a year now, have been considering transitioning most of our CAD tool framework to the cloud. We hadn't quite pulled the trigger on that yet. So most of the tools still run using an on-site compute farm. But we have very good remote access to that. We have a very high-speed connection to the company data servers. And so we have really good access. If someone's got a broadband connection at home, and most people do, we have very good access to those tools. And using the tools like, let's say schematic capture and cadence or IC layout is a little bit slower than it would be from the office, just due to the extra network hops. Those tend to be pretty interactive applications.
Yeah.
It's a little bit slower, but for the most part, it's not a lot different from working in the office. The willingness and the creativeness and the perseverance that this team has shown in this situation that we find ourselves in right now has been nothing short of inspiring.
This segment of our show is sponsored by ECIA. ECIA's members include the leading electronic component manufacturers, their manufacturer representatives, and authorized distributors. They collectively share a common goal of promoting and improving the business environment for the authorized sale of electronic components. ECIA provides resources and opportunities for members to improve their business performance while enhancing the industry's overall capacity for growth and profitability. For more info, go to ecianow.org.
Earlier this year, Medtronic ramped up production of their Puritan Bennett ventilator in response to immediate and significant global demand. California-based Royal Circuit Solutions is helping to meet Medtronic's production needs by manufacturing the printed circuit boards that control their ventilators. Mark Hughes joined me from his home office in California to share how Royal Circuits is keeping their production lines going to help meet the surging demand. There are a lot of PCB manufacturers, right, and assembly houses all over the world. How did it come to be that your company found itself partnered with Medtronic on the production of these life-saving ventilators at a time when we can't produce them fast enough?
We've actually been working with Medtronic for a number of years now, working on their PB80, and I think it's the PB840, so that's the Puritan Bennett 840 respirator line. So all they had to do was call us and say, hey, can you make more of these than you usually do each month? And we did. We basically just cleared the production lines down at our Santa Fe Springs facility and moved all of those jobs up to our Hollister facility. We don't like waiting, right? We like being the fastest company out there. So we keep millions of dollars of raw materials on hand.
Oh, nice.
We don't want to wait a day or 2 days or even 6 hours to go and find one of our suppliers and say, hey, can you give me some 1 ounce copper? We want to be able to go walk over to the shelf, take it off, drop it on the machine, and get cracking.
Yeah.
So we were able to start basically as soon as we hung up the phone with Medtronic.
Yeah, and these are life-critical machines, so, zero manufacturing defects is presumably a non-negotiable term. Is that accurate?
Yeah. Medical is really top-of-the-line stuff. When you're manufacturing these class 1 products, that's IPC class 1, you got to figure that half the boards that you're going to make are going to go into the trash. Any small error is enough to reject them. Mm-hmm. It could be something as simple of a slightly misaligned via pad in a drill that's wandered a little bit too much. So now you don't have enough pad around the drill hole. It could be something as small as half a mil, and it causes us to reject that board. Mm-hmm. We're that particular about the product we put out.
Now, in a production facility like this, what percentage of Royal Circuit employees are working from home right now, with the shelter-in-place orders?
I'm just spitballing here, but I'd say, something like 90% of our employees are working from home.
Oh, good.
Unless you're an actual line worker, there's really no reason for you to be in the shop right now.
Right.
So that's all of our engineers, our layout engineers, our salespeople, our accounting. Anybody that can be home is home. So the only people that are inside the facility are people running the actual machines. And each one of those is compartmentalized to their workstation, which are luckily in these semi-clean room environments. We got glass doors, separate airflow to keep all the dust and everything down so, we don't contaminate our production line. Well, turns out that also makes it COVID compliant. So it just kind of worked out well.
Now, going line down in this case just is not an option. Never is, but especially now. For people who are on the production floor, how are you ensuring that the workers are staying safe and healthy and able to perform their jobs to keep these lines up?
So all of the production process teams are in their own little separate rooms. I don't really know all of them have it, but I know in several rooms we've got these little pass-through slots that you can actually take the panels and shove them from, station 1 to station 2. Now, those are mostly installed for clean room purposes, but it also works out well from a COVID-19 safety standpoint too. Mm-hmm. So in the smaller rooms, we just have one employee that is, sitting there and shuffling the boards from one machine to the next. And then as you get into the larger rooms, like the wet process, and this is a big room, 800, 1,000 square feet. Yeah, you can easily have 2 or 3 employees in there, masked on, gloved up, and moving around the machines while still being, 15, 20 feet from one another.
Nice.
But yeah, we're doing everything we can to keep the employees safe and separate. Everybody's got masks, everybody's hand sanitizing and washing their hands, everybody's wearing gloves.
It isn't just coworkers that you need to work with remotely, right? As a fab house, you need to stay in touch with your clients to make sure that their design is in fact manufacturable. And in fact, you can lose a lot of time with just a simple design rule violation. So what are some of the more common mistakes that you see when you receive layout files from customers? And how can what guidance would you lend to an engineer to help them prevent making these mistakes and introducing, time delays into their PCB manufacture process when they're under the gun and absolutely need top yields with successful boards? For example, if a company needs to change some aspect of a ventilator design, for instance.
Top manufacturing mistakes. I would say probably the first one is violating trace and space guidelines. Copper, when it etches down on a board, it doesn't go straight down. It kind of creates this trapezoid shape. And if you have 2 traces that are next to each other and those 2 trapezoids happen to intersect, you're not going to get any airspace between those traces. You're going to create a short circuit. Mm-hmm. So every piece of copper has to have a minimum thickness so that when it etches down, there's still a little bit of copper left at the bottom. Otherwise, your trace will roll. And they've got to be separate enough so that we can actually get some acid in between those traces to start etching stuff out.
Right.
So it's always a best practice to find out what the manufacturing guidelines for your particular manufacturer are. And they should have these things set up. And then you can have them do a DFM check, design for manufacturability, where they can actually tell you, yeah, this will work, no, this won't. If I had to pick number 2, I would probably say vias. So vias a vertical interconnect access. It's a connection between parallel layers of copper. And the way that it's made is we lay out the board, we drill a hole through it, and then we put it in our plating tanks and let the copper build up on the inside of the holes there. you need little bits of copper that go around these drill holes so that there's something to plate to.
Right.
So oftentimes we'll see people do vias that are too small, and then they'll do insufficient pads. Mm-hmm. It's something where you want to talk to your manufacturer and find out what their minimum specifications are. Go a little bit higher than that if you can. But just get a conversation going and make sure that you have those in your design rules.
Awesome.
See, another thing, probably number 3, I would say running copper right up to the edge of your board for no good reason. There are good reasons to take copper to the edge of your board. If you're going to do some edge plating for RF work, for example, okay, no problem. I'm talking about a standard design, and the customers run the top layers 1 and 2 of copper all the way to the edge. We run the router down to cut those things out. You've got exposed copper from 2 different nets that are really, really close to each other. It's incredibly easy for that copper to short out, and we've got to throw the board away. So that's no good. So we always recommend that they inset the copper from the edge of the board a good 12 to 15 mils just to prevent that from happening.
Nice. This is great, by the way. What are some more? What are some other things that you see that cause problems?
Do you mind if I do an assembly mistake?
No, dude, go for it. I'm just, I love this. I'm feverishly taking notes.
This is something that we see every day at one of our partner companies, Advanced Assembly, and I'm sure assembly houses all over the place. Mm-hmm. People put the wrong package sizes on the wrong landing pads, and they just don't fit. They won't solder. Or if you do, you're going to get an unreliable connection. You're a designer, you pick the right package, and it costs 33 cents. And then you take your design, you throw it over the cubicle wall, and purchasing gets a hold of it, and they say, hey, I found that very same part for 1 penny less. Let's order that one. Okay, that sounds like a great idea, except the first package was a QFN and the second one's a TSOP. It's one of those things where slot A or a tab A doesn't fit into slot B. They just don't mesh. But another problem that I would say is common, and it happens to absolutely everybody, is the trouble with discrete component package sizes. These things are all standardized, and I'm sure you're aware that there's, 0603, 0805s, 1206s, 1210.
Yeah.
When you and I talk about those, we're usually referring to imperial measurements. But America is the only country that uses imperial. The rest of the world uses metric. And here's where things get tricky. The 0402 package size, there's a metric 0402 as well as an imperial 0402. And the size of the metric 0402 in imperial measure is 010-005.
Oh, man.
Right? So that's no good. The 0603 package imperial is a 1608 in metric. All right. But metric also has an 0603. That's the 0201 in imperial.
Ruh-roh.
See where this is getting tricky? Yeah. So whoever numbered these things came up with several identical packages, and man, does that make for a mess. The fifth mistake that people make, and maybe this should have been number 1, but let us run this through the DFM and DFA checks. Design for manufacturability, design for assembly. Mm-hmm. It's free. We don't charge anything for this, but let us go through your design and look for problems before you order it, before you decide, hey, I need this tomorrow. Because, something like 90% of our projects go on hold for one reason or another. Get the conversation going before you get so deep in it that it's going to take you 3 days to fix your mistakes.
90%. Holy smokes, man. That's incredible. Hey, one last question for you. Is this, getting back to ventilator production, a lot of people are excited about this, and they're scrambling to come up with solutions, which is really cool. In some ways, it's good to see human beings stepping up in the face of a challenge like this. But is this the right time to be, say, innovating? Or should we be doubling down on sort of proven technologies, proven solutions, and proven manufacturing processes?
I have seen a lot of stories lately about people that are manufacturing new ventilators. There's an MIT team, a NASA team,
Yep.
the vacuum people. I forget who they are.
Tyson.
It's like, hey, look at us. We designed a ventilator from the ground up in 14 days. Sure, okay, I understand the desire to jump in and help. I do. I get it, and I think that is wonderful. But in my opinion, we do not need new, unproven ventilator designs. We don't. We need a ventilator that's worked right for the last 10 years and has proven track record of success. Because the problem with these new ventilator designs is something that is 99% reliable is going to leave a patient 100% dead. These designs take away from established manufacturing capability. You know, Medtronic, who has experience making ventilators, isn't cranking out new ventilator designs right now. They're cranking out tried and true designs. That's what we need.
Right.
I love innovation. I love that these people are trying to help, but you cannot experiment ethically. You cannot experiment with a human life. You just can't do it.
Our final segment is sponsored by digikey. digikey offers the world's largest selection of electronic components in stock and available for immediate shipment. From prototype to production, digikey fuels innovation globally as the leader in product availability, on-time delivery, and overall performance. At digikey.com, you'll find more than 10 million products available from over 1,200 component manufacturers with 24/7 customer support and 99.9% of orders shipping the same day. digikey, the world's largest selection of electronic components available for immediate shipment.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem. We've had a main beam bus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
As a senior staff engineer on the mission operations team at Lockheed Martin Space, Dave Gingrich has, for most of us, redefined the phrase working remote. Since joining Mission Ops nearly 20 years ago, Dave has never been closer than a few 100,000 miles from his equipment. That's because his equipment is currently orbiting Earth, Mars, and Jupiter, which is fine as long as you're sitting next to other ops engineers when there's a problem. But ever since the middle of March, Dave and all of his colleagues at Lockheed Martin have been flying deep exploration spacecraft from home. Oddly enough, this month marks the, 50-year anniversary of Apollo 13?
That's right.
Now it's April 2020, and we've got a very odd state of disaster all over the world with this COVID-19 pandemic. Mm-hmm. And one of the effects that it's having on companies, especially, technology companies that already have a lot of distributed teams, everybody's working from home now. Mm-hmm. What are some differences that you've observed in sort of the working dynamic with respect to working on a traditionally distributed team geographically, but now where teams are globally distributed and sheltered in place?
I think some of the differences are, some of the early differences were just how to do this, how to conduct, how to do a Skype meeting and what number are we supposed to dial into, and did everybody get the notice? Some startup kinds of things. Most of those, I think, have gone away now. But what's left now are kind of the hard ones to crack. We've been able to transfer most everything that we used to do in the office. We're trying to maintain some semblance of the way it was by exchanging photos, sharing. Well, what does everybody's office setup look like?
Yeah.
What does, we had one this week it was team day. Everybody was supposed to put on apparel or something from their favorite team. Okay. And send a photograph into the management. And, and some people are really creative with it. And boy, some people have some really nice looking offices. I'm amazed.
There's a lot of creativity just in that, keeping the culture alive too. Whoever's coming up with these ideas to keep the personal connection, that person should be applauded.
Yes, I agree. It's not something that I would really excel at, but keeping people connected that way is still pretty important. And I think one reason it works for us is that culture was there before we had the stay-at-home orders. is that people made efforts to be connected, to even share some outside activities occasionally, to have a burrito day where management supplied burritos for lunch for everybody. Just sort of networking, work bonding.
You recently had a situation where you had a spacecraft go into what you described as a safe mode, and it was during the wee hours of the morning. Everybody was asleep.
Yes. Mm-hmm.
Can you describe some of the challenges that you are facing or that you will face now in debugging, testing, and resolving the issue without being in the same physical location as your coworkers?
In fact, it's Mars Reconnaissance Orbiter, and I think some of the issues there is that the communications gets to be so slow. If you're not present in a conference room or all gathered around at your separate consoles, I know that systems people sit over there, telecommunications is over there, and attitude control is next to me. You can't rapidly bounce questions and ideas off of each other. Mm-hmm. You have to go through some kind of email is horrible.
Yeah.
Instant messaging is horrible.
Yep.
You can't have somebody come by and just say, what? Ask a question like, I overheard what you're talking about. And that's not the way it goes. So that quick communication, that's tough. I think the other thing that would be difficult is that here, I feel anyway, particularly limited to what I have on my screen right in front of me on a little tiny laptop. Whereas if I'm in the office, I have 4 terminals up and 3 different networks, and I can find all kinds of information so quickly. It's slower here. And I think for a team that is trying to recover a spacecraft, I think the slowness in communication is one thing that they're going to have to really struggle with. And I think when you try to go and debug, you want a whole bunch of information, and somebody will come up with an idea. Again, that goes back to cross discussions with your teammates about, but if that was true, then we should see a thermal response over here. Or somebody else tells you, but it doesn't respond that way. It has to wait till the count gets to 50. Mm-hmm. It's just going to be really tough, I think, for them to try and get all of that information together and to be able to work on it.
Yeah. That's you lose so much collaborative, I guess, the information that sort of crackles and comes to life when you're in a collaborative setting. As much as everybody dreams of that job where they get to work from home, and you hear a lot of I can work from home. How come we don't have a policy that supports it? Mm-hmm. Were there moments in your own career that you can look back and think, if I hadn't been in person in the office when this happened, my career would have gone on a completely different trajectory?
I don't know about my career, but I do know there are instances when there's a little bit of serendipity, and being in a collaborative environment, we're doing something on the spacecraft. The customer is there to watch, and it doesn't work. And then you really, personally, you want it to be as a team. You do not want to be the only person, right? Believe me, we've had lots of issues and failures. I mean, everybody does, but we had one once, and the phone out there on the console, on the spacecraft console, rings, and it was our executive vice president, and he's calling, "What's going on over there?" Oh boy. I have got to find a manager right now because I don't want to talk with him. It's like, this is management's job. That's what they're here for.
Oh boy.
And so I think part of it is just the camaraderie. The personal togetherness is important, especially when things get tough, and they can get you can have a really, really bad day in space. Mm. And if you're working all by yourself in an isolated location, I don't think you'll get that sense of being a part of something much larger and having the kind of the high level view that, you're really participating in something that needs to work together.
Mm-hmm. Yeah.
You can't be part of a string quartet and have everybody playing, in their living room and then mailing the parts in.
At some point, everyone is going to retire. What problems do you think you're just starting to stumble into that companies will have to be solving for around the time that you envision yourself retiring? And will you feel a little envious that you won't be involved in those efforts professionally?
Oh, there's lots of things. I'm probably already envious of. When all this space exploration stuff that we've done is nothing. The real big stuff is still out there. So I'm envious of future engineers exploring Europa, for instance, or Enceladus, where they may be the first to find life off of the Earth. And the future exploration, the first people that are going to walk on Mars are alive someplace right now.
Oh, wow.
They might be in 6th grade. You and or I may have met them already. We don't know it, but they're out there. First person to walk on Mars, first people are alive somewhere. I'm really going to miss it. I'm really going to be jealous and envious of all the cool stuff that they're going to do and discover. Eventually, Homo sapiens, we must leave the Earth. We cannot live here forever. The sun will die, the Earth will die, all life here will die. And we can't go live on Mars. We can't live anywhere in our solar system.
Right.
So what are we going to do? And I'm looking at it as human beings, Homo sapiens. We have to do an evolutionary jump from terrestrial beings to space beings. That is, we live solely in outer space. We don't live on a planet anymore. And it's, that's probably the big idea that I'll never, ever see, coming about, because there's so many challenges for us to, for one thing, you have to be able to collaborate with a committee of 10 billion members. So how are you going to do all that,
And get anyone to agree on it.
Who gets to leave and who has to stay?
I've got opinions.
There's just... Right. Yeah. Can we send some of them right now?
Right. This has really been a lot of fun and personally very enlightening. Thank you so much for the generosity of your time and energy.
Oh, you're welcome. I don't mind talking about this stuff at all. It's like, a little kid who goes outside and finds a pretty rock, and the first thing they want to do is run inside and share it with mom and dad.
I'll bet you're seeing things. You're seeing things for the first time humans are seeing them. And
oh, yes, I have had that experience. Yes, it's fun.
What does that do for you when you're seeing something that humanity has never witnessed before? And for you, it's in a day's work. What emotions wash over you as you're realizing this?
I think it's that it's like a child discovering something. You just look at it in amazement, mouth open. And I've been around this with other people too. And it's so fun to watch these uptight scientists and engineers start jumping around like little kids when they see something unexpected or that nobody has seen before. It's just excitement. It's what keeps me going in this job. Once you do it, you want to do it again or support others who are going to do it. It's sharing that excitement.
As engineers, we tend to be self-sufficient, but we also depend on teams, maybe more than we even acknowledge. For many of us, being separated by this pandemic has only served to highlight how we work together. Luckily, we have the tools and the talent to design bleeding-edge ICs while in isolation, to safely man manufacturing floors to ensure the production of critical devices, and to continue developing technology that's sent into the loneliest parts of our solar system. The way we work may have changed, but the importance of our work has not. So, how has COVID-19 affected your work? Send us a tweet, an email, or leave a comment on All About Circuits to share how your team and your company are handling the pandemic. Thanks for listening.